Hello, Mindsetters, and of course, today it is our Triple M, which is Mindsetters Maths Monday, and my name is Abram. I'm not alone. I'm with Temlin. How are you?
I'm good. How are you?
I'm super charged. I'm ready to learn a lot today.
Absolutely. I'm loving this Maths Monday. I think it's awesome.
Yeah, it's just Triple M. Mindsetters Maths Monday. That's how we
I
roll.
think that's an awesome concept.
Right. Talking about that, what are we doing today?
Today, with upcoming exams, which is looming around the corner, we're going to be having a look at all the algebra that we've actually covered over the last little while, and just to give everyone some good revision.
Nice one. It's a great build up to that revision.
Yeah, absolutely.
Right. Awesome. Please go take your position.
Thank you.
Right, Mindsetters, as you've heard that today it is our Triple M day, which is Mindsetters Maths Monday. There are three things also that you need to do to tune in and to make sure that you participate on this show. One, you need to log on Facebook, take your cell phone next to you or your PC just next to you, and then let's go over Facebook. Our Facebook link is facebook.com/LearnExtra. You can also tweet me at LearnExtra. And lastly, you can download today's show on our link, which is learnextra.co.za/live. That's how we roll. That's how simple it is. And I'm just so happy that over Facebook, we've just grown Mindsetters. We are now about 41,000 and something. And yeah, if you think that we can reach 42,000 anytime soon, keep those guesses coming and you could win this t-shirt. More details are on our Facebook page. But for now, let's learn more algebra with Temlin. Take your time.
Thank you so much. Right, guys, as I mentioned, exams are coming around the corner and it's time to start revising. So now is a good time let's get out the algebra books. Let's go back to what it was that we learned right in the beginning and just make sure that we are not forgetting any of those concepts that it's so important that you need to really have a firm grasp on. Okay, so let's have a quick look and see what it is that we're going to be doing today. In our lesson, we are going to be having a look at how to find products and factors. Okay, so simplifying, factorizing. So those are two important concepts. Algebraic fractions, guys, you are guaranteed to get those in your exams, so we've got to make sure that we know exactly how to tackle those. Laws of exponents, right, that's something everybody tends to have a little bit of difficulty with, so we're going to have a look at laws of exponents, a really important section with regards to theory, okay, so you need to go and learn those laws of exponents. You need to have a really firm grasp on the laws of exponents so that when it comes to applying them, we know exactly within what parameters we can work in terms of the laws that we have, okay. Right, working with patterns, okay, our number patterns. Remember we had this set of numbers and we had to decide, was there some kind of pattern there? A common difference maybe? I'm sure you guys remember that, okay. All right, then we're having a look at equations, right. Just to refresh your memory, equations, remember, is where you are solving for a variable. So solving for x, it doesn't always have to be x, but that's normally the typical one. And there are different types of equations. So what we learned this year is that we don't only have a linear equation, but we've kind of opened the gates to that. We worked with quadratic equations, which we need to make sure we remember, simultaneous equations, and even our inequalities. So we've got lots to get through today, so let's not waste any time. Let's get going with the very first question I would like to work through with you, and that is simplifying. Okay. Guys, please watch out in your instructions when you're reading your exam paper and you're actually reading the instructions that are in front of you. The word simplify has a very different it's expecting you to do something very different to as if you were asked to factorize, okay? Simplifying is telling us to get rid of our brackets. We need to distribute, we need to FOIL, we need to get rid of the brackets. However, factorizing, remember, is the opposite process. There we're putting everything back into brackets. So in this case over here, let's have a look. We've been told to simplify the following algebraic expression by expanding fully. Okay, the reason I liked this example over here is because this little bracket of 2x minus 1 is being squared. Now, grade 10s, I'm going to point out a really common mistake here. And guys, by pointing it out, I really hope that you realize that you cannot do this. And this is an important thing to watch out not to do. You may not just go squared, squared. Okay? If you've got a binomial in a bracket and that binomial is being squared, you are not allowed to just go squared, squared. So then what are you allowed to do? All right? Let's think about this logically. The whole bracket is being squared. So essentially that means that the whole bracket is being multiplied by itself twice. And by writing it out twice, I'm sure you guys will agree that you can then see what it is that you're supposed to do. We need to FOIL it, okay? And that's what you've got to remember. Please don't just go squared, squared. It's such a silly mistake to make, okay? Right, then I've got these two brackets over here. I've got a minus, all right? And the minus is obviously being multiplied to your brackets, but I've also got two brackets being multiplied together. So sometimes people have the problem where they say, okay, well, what do I do first? Do I distribute the negative first and then FOIL? Or do I FOIL first and then distribute your negative? What I'd like you to remember, grade 10s, is if you have a situation like this with a term outside your bracket, plus you've got two terms being multiplied together, FOIL first, all right? FOIL it out first. Once it's then FOILed, then distribute the negative. That's how you need to deal with this, okay? So what we're going to do is keep the negative outside, and we're going to FOIL these two brackets. So let's quickly do the FOIL. That would be firsts, outers, inners, and lasts. Okay. If we do first, outers, inners, and lasts, what we're going to land up with is an x squared. We're going to get a negative 3x from our outers, and we're getting a positive 3x from the inners. Now, a negative 3x and a positive 3x are just going to cancel each other out. So let's leave that. We don't need that there. But our last, positive 3 times negative 3, is giving us negative 9. All right, and we've got plus x squared. Just remember over here, grade 10s, that if you have got two terms that look exactly the same, except that one bracket is a plus and one bracket is a minus, remember that that's called difference of two squares. Two terms, they look exactly the same, but one's a plus and one's a minus. So if you have difference of two squares, the shortcut around that is that you don't have to go and do the whole of FOIL. We just multiply our firsts and our lasts. Okay, it's just a shortcut. It's there to just help you save a little bit of time in your exam. Okay. All right, so let's finish this off here. We're going to FOIL the first two brackets out. So when I times my first two terms together, we get 4x squared. When I multiply my outers, we get negative 2x. And when we multiply our inners, we get another negative 2x. Now, those are like terms, so we can put it together to be negative 4x. And finally, when we multiply our lasts, we get positive 1. Okay. Right, we've squared out the difference of two squares, so now we are able to distribute the negative. So now it's negative x squared plus 9. And lastly, we've got this x squared that's hanging on at the end there, and nothing's really happened to it just yet. Okay, so we've remembered that if you've got a binomial that is being squared, we are not just going squared, squared, we are FOILing it out. If I've got two terms that are being FOILed and there's a negative in the front of the bracket, FOIL it out first, then distribute your negative. Okay, remember that order, guys. And once we've done all of that, that's the hard part done. Now we just look for like terms. So let's gather up. I've got a 4x squared, I've got a negative 1x squared, and a positive 1x squared. That's going to simplify to just 4x squared. We've got a negative 4x. There are no other x terms, so that's going to be negative 4x. And finally, I've got a 1 and I've got a 9, which is going to give us 10. Okay, and that's it. That's as simple as I can get that expression to be. Okay, so we've gotten rid of the brackets and we've simplified the expression. Okay, so that's simplifying. Then your test asks you to factorize. Okay, now remember, guys, factorizing is the opposite of simplifying. Simplifying, get rid of the brackets. Factorizing, you want your sum in brackets. Remember, the point of factorizing, grade 10, is that you want the final term, the final answer at least, to be one term. That's when you know that you have factorized and at least factorized fully. Okay, so look out for that. That's the thing to watch out for, is that your factorized answer is one term. Okay. All right, so let's see. There's different ways of factorizing. That's the other thing. Now, the way I describe it and the way we teach it is that I want you to think about factorizing as a layered process, okay? And the first layer that you're always going to consider is your highest common factor. Once you've dealt with that layer, you're then going to say, okay, well, if it's two terms, could it be a difference of two squares? If it's 3 terms, is it a trinomial? And if it's 4 terms, can I apply grouping? So you've got to approach it from a layered point of view, okay? So let's see if we can do this one in that manner. First thing you always check for is a highest common factor. Even if it's a basic sum, you check for that first. In this particular case, I don't have one. There's nothing that's common throughout all the terms. The next thing I can see is I'm sitting with 1, 2, 3, 4 terms, which means I need to apply the rules of grouping. Grouping, generally, it's a good idea to start with the first 2 and the second 2 terms. If that doesn't work, then you can try other combinations. But I would suggest starting with your first 2 and your second 2 terms, just as a starting point. Okay, and once we've done that, we look for our highest common factor. Now, in my first bracket, I've got a b that's common, leaving me with a 5a from my first term and a 3 from my second term. Then I've got, in my second bracket, I've got a common 2 that's going to come out. So now if I take out that 2, I'm going to be left with a 5a minus 3. Now that, guys, is exactly what you want, because can you see that the brackets are the same? You've got the same brackets, okay? So what are we going to do with them now? We're going to take out the highest common factor again, and that happens to be the whole bracket of 5a minus 3, okay? So that bracket has come out as a common factor. What am I left with? A b plus 2. All right. Okay, so that was grouping. All right, I hope you guys remember that. Go and practice it. There are a few things to watch out for with grouping. Things like leaving a negative outside of brackets. Remember, just go and practice that, guys, that it changes the term inside the sign inside the bracket. So it just needs a bit of practice. Go and look through your notes that you did earlier in the year. Right, trinomials. Okay, so we're having to factorize. They've asked us to do that. So we know in our exam, you're going to say to yourself, okay, I know that I have to put them in brackets. So having done that, the first layer that we're going to have to consider is the highest common factor. Let's look at the first one. I've got x squared plus 12x plus 36. I'm sure you agree there's nothing common. So I can't worry about that. So let's look at the next layer. It's not a difference of 2 squares because there's only 2 terms. Could it be a trinomial? Well, in this case, yes, it could, because there's 3 terms. So let's see if we can factorize. A trinomial, we break it into 2 brackets, and we start by saying the square root, or the x squared, I'm going to just separate and give each bracket an x and an x. And then I say the factors of 36. What times what gives me 36? That's going to get me a positive 12 when I add or subtract them. Let's see. If I've got 9 times 4, that's going to be 30. That's not going to give me, let's see what else we've got. 36, 12 times 3 is 36. And I don't know if I'm just being silly here. What are the factors that are going to give us that? Okay, I'll think about that and just get the answer done now. Okay, factors of 36, that would get you to 12. If that doesn't work, I'll have a look at it in a minute. Let's have a look at the one that has a term in the front and at the back. That one is an important one for you guys to watch out for. All right. If you've got a trinomial, guys, where there's a factor in the front and a factor at the back, this is where you've got to watch out for just having a good grasp on a method, okay? The method I'm going to use might not necessarily be the method that you've learned in class, and that's fine. You may have learned a different method. Point is, you need to just have a good understanding of a method, all right? So let's just see how I'm going to go about doing this. The factors of 6, the first term over there I'm going to say is 6 and 1, or 3 and 2. And the factors of 9, I've either got 9 times 1, or I've got 3 times 3, all right? Now, what I actually want to do with this is I want to cross-multiply all the way over this middle line over here. And ideally, what I'm trying to find is 2 terms that when I add or subtract them is going to get us to negative 15. So let's try over here. If I cross-multiply this term, the factors of 6 and 1 with 9 and 1, do you guys agree with me that 6 times 1 is going to give me 6, and 9 times 1 is going to give me 9. Now, will 6 and 9 get us to 15? Well, in fact, yes, it will, okay? It will, as long as we have the correct sign. So let's see. In order to get to negative 15, I would have to have a negative 6 and a negative 9. But there's a small problem here, because if I have a negative times by a negative, that would give me a positive, and over there, that's a negative. So we need to watch out. Let's see what else we can do here. If I were to take other factors, let's use a different color. If I were to take the 6 times the 3 and I were to take the 1 times the 3, let's see what that gives me. 6 times 3 gives me 18, and 1 times 3 gives me 3. Now, in fact, I can get a negative 15 with those terms as long as my 18 is negative and my 3 is positive. And a negative times a positive would give you negative. Okay, so everything's kind of lining up here. Let's see what it looks like in the brackets. I'm going to bracket the first 2 terms, the top, and bracket the bottom, and that's what my brackets are going to look like. I'm going to have a 6 and a 3 in my first bracket, and I'm going to have a 1 and a 3 in my second bracket. Both of them are going to have x's, and I'm going to make my 6 times 3, that needs to be negative 18, and that needs to be positive 3. Okay, guys, it's just practice with regards to that method. Go and practice it. That really is important. Okay, we're going to have a quick break, and we're going to continue with factorizing when we get back, so don't go away.
Right, on that note, Emlyn, thank you to all the mindsetters that are on the page, learning a lot, such as Pinach, Maloka, Yanish, Disa, and Api was saying they're enjoying the show and also answering some of your questions. So I like the engagement of our Facebook page. Mindsetters, let's keep it like that. See you after the break. Welcome back at Triple M's Mindsetters Maths Monday. Hope you're still enjoying the show and learning a lot. Thank you very much to all the Mindsetters that are helping me and Tamlin over our Facebook page. If you just joined us now, you are late, but you can still catch up. Go over Facebook. Our Facebook page is facebook.com/learnextra. There are so many details coming soon and so many giveaways that are coming soon right on this very same show. So for now, let the learning continue.
Okay, I think my brain's still on slow Sunday and not Maths Monday, because 36 is 6 times 6, which many of our Facebookers obviously told you. So sorry, grade 10s. We've got a 6 and a 6, which would obviously be the correct way of factorizing that. Okay, right, let's look at some more factorizing. Okay, we've got 16y cubed minus 432. Okay, so we know we've got to factorize it. So you're going to go through the process. And the process is there a highest common factor? Well, let's look carefully. I've got a 16 and I've got a 432, okay? So grab out your calculators and just see if 16 wouldn't actually happen to go into 432, all right? So check that out quickly. And I'm sure you've worked out that it does, okay? There is a highest common factor of 16. So I'm going to take that out, which is going to leave me with y cubed minus 27. Right, now, this is the type of factorizing you would have learned this year, that this is now what we call a difference of 2 cubes. So the method of factorizing difference of 2 cubes, we keep our 16 as the common term outside, and we open a binomial bracket, and then I open a trinomial bracket. And we start by taking the cube root of both the first and the second term. So the cube root of y cubed is just y, and the cube root of 27 is 3, okay? Then to find the terms in the second bracket, I take the y and I square it. And y times y is y squared. I take the negative 3 and I square it, which makes 9 at the back. Then what you do, guys, is you times these 2 terms together. So you take y and negative 3 and you multiply it together, which is negative 3y. And what we do is we fill in 3y as the middle term there. The only thing to watch out for is that if it's a minus in the first bracket, we make that a plus in the second bracket, or vice versa. So whatever the sign was in the first bracket, it changes in the second. Okay, I'm quickly going to do number 2, which is also a difference of 2 cubes for you, just so that we can just make sure you understand the method. All right, for this one over here, 64x cubed plus 1. So I've looked for a highest common factor, and there isn't one. So I'm crossing that off my list. Now we're going to see if it's difference of 2 cubes. 64 is a perfect cube, so that's great. 1 is a perfect cube, so that's great. And now let's see what we can do with it. I'm going to open a binomial bracket and a trinomial bracket. The cube root of 64 is going to be 4x, and the cube root of 1 is 1, okay? Then I take the first term and I square it. So 4x times 4x is 16x squared. I take the last term and I square it, so 1 times 1 is 1. And you times these two terms together. So 4x times by 1 is 4x, but because you've got a plus over here, that's going to be a minus. So we say minus 4x. Okay. Just something interesting about the number of 64 and 1 is that both of those numbers happen to be perfect squares as well as perfect cubes. So it's quite interesting that, in fact, those two numbers could be used in difference of 2 squares as well as difference of 2 cubes. Okay, all right, guys, so we had a look at simplifying, getting rid of brackets. We've had a look at factorizing, putting it into brackets. Let's have a look at another simplifying, but this involves fractions, which I know is everybody's favorite. Okay, if we are simplifying a fraction FOIL sum such as this, my first suggestion is going to be this to you guys. I'm going to change my color. We've got an x minus 2/3 multiplied by x plus 1/3. Okay, what I'm going to do is I'm going to just balance my sum. Both of those x's, because they didn't have a denominator, it kind of felt like the sum was imbalanced, okay? And if you ever have something that's a whole term or a whole number and a fraction, if you want to make that whole number balanced, just put it over 1, okay? And then everything has got a numerator and it's got a denominator, and it's much easier to work with. Right, now we're going to do FOIL. So we're going to times our firsts, outers, inners, and lasts. And when you're multiplying your terms, it's as easy as this, guys. We need to multiply the top with the top and the bottom with the bottom, okay? So my x times my x is going to give us x squared, and 1 times 1 is going to give us 1. If we do our outers, 1 times by x is obviously 1x, and 1 times by 3 is 3. Inners, negative 2 times x is negative 2x over 3 times 1, which is 3. And then your lasts, 2 times 1 is negative 2 over 3 times 3, which is 9. Okay. And once we've done that, that's the hard part done. They are my like terms, so I'm going to put them together. We don't have to keep x squared over 1. We can just write it as x squared. It's not necessary. And what have we got here? If I've got 1x minus 2x, that's going to leave me with negative 1x over 3 and minus 2 over 9. Sorry, that looks like a bit of a 3 now. Minus 2 over 9. Right, there we go. So don't let fractions and FOIL phase you. It's not necessary. Just make sure that all your terms have both a numerator and a denominator, and you just apply your FOIL, multiplying top with top and bottom with bottom. Okay. All right, guys. So what you are going to do is go and practice that FOIL, your distribution, your factorizing. Make sure that those are the easy marks in your paper, because if you've practiced those enough, it's really not too difficult to get those right. Okay. Right, then we've got algebraic fractions. Now, this is always going to be in your exam. You're always going to get something along these lines. And it's basically taking the factorizing and the simplifying and kind of throwing it all together into one question and seeing what you can do with it. Okay, right. The golden rule of an algebraic fraction is this. And I know your teachers have said this to you. You may never, ever cancel over a plus or a minus. Ever, okay? So what does that mean? That means that no matter how tempting it looks to cancel that 6x with that 6x, you may not do it. It is an absolute incorrect thing to do. Okay? So that's out. You cannot cancel those no matter how tempting it looks. So what can you do? Your only way out of this problem, guys, is to factorize. All right? You're going to take every single numerator and denominator that you have in the sum. You're going to factorize your heart out. You're going to see if you can factorize as much as you can. And once you've done that, then you're going to cancel. Okay, so Looking at my first numerator, I've got 3x squared minus 6x. So do you guys all agree? I've got 3x as a common factor, which means I'm going to be left with x minus 2 in my bracket. Okay, the term 6x, I actually can't simplify that any further or factorize it any further, so that's as it is. Instead of divide, remember we're going to change divide to times, and it means we have to invert that fraction. So it becomes 4x squared over x minus 2. And nothing else can factorize. If it could, I would do it, but nothing else at this point is able to factorize. So we're done. We've taken care of any brackets that we needed to take care of. Now we get to cancel. So that whole term of x minus 2 cancels with that whole x minus 2 over there. That x will cancel with one of the x's on the top. I've got 3, which is going to go into 6 twice. That 2 is then going to go into 4 twice. And what are we left with? I've got an x over there. I've got an x over there. And everything else has cancelled. So x times x is x squared. And that's it. It's cancelled. It's simplified. All right. So just watch out, guys. Never cancel over a plus or a minus sign. And just watch out that you make sure you factorize everything properly. Just a quick thing over here, which I'd like to add just before I move on to the next question. Let's modify this slightly. What I'm going to do is this. I'm going to write the sum as this. 3x squared minus 6x over 6x divided by, and I'm going to write it as 2 minus x over 4x squared. Just because when we set our exams, we don't want to make it that easy, so we want to just add 1 or 2 little twists and turns in the sum here, and this is one of them. Do you guys agree that what I've done is I've actually turned that around? I've made that a 2 minus x instead of x minus 2. So I'm not going to redo the whole question. I just want to deal with that part of it over there. Remember, if you've got terms that are essentially the wrong way around, I had an x minus 2 when I factorized the numerator, and I wanted it to cancel with that over there, but x minus 2 is not the same as 2 minus x. So remember your rule that if you put a negative outside that term over there, you would be able to swap them around and write it as x minus 2. And by doing that, you would then be able to cancel out. So bear that in mind, that if you've got two terms and there's a minus between them, just what if you had, for instance, 2 plus x, grade 10, that doesn't matter. 2 plus x is exactly the same as x plus 2. So that's got no problem. But it's when it's x minus 2 and 2 minus x, that's where you have a problem. So in order to turn the terms around, you put a negative outside the bracket, and you can then swap the terms around, and then you can sort it out from there. Okay, so just watch out for that.
Right, Tamlin, before you move on.
Yes.
There's a mindsetter by the name of Mtsasa who says, can you please repeat what you just said? Because my maths teacher said that when it's 1x, we don't have to put in 1.
She's right about that. Let's go back to this for a second. I'm not sure exactly what part of it I'm assuming maybe she's referring to putting it over 1.
Yes.
Okay. Any whole number, let's take the number 6 for instance, can be written as a fraction by putting it over 1. Okay. The reason why is because 6 divided by 1 is still 6. All right. So if ever you want to take a whole number and convert it into a fraction, you can put it over 1. However, do we have to write every whole number as something over 1? No. We all know that if it's over 1, then it's just the number itself. So if I understand what you're asking me, why did you drop that 1 down below there? Because you've got x squared over 1, which it's a bit redundant. There's no value to having it as over 1. So then we just wrote it as x squared. So I hope that helps. I hope that was answering the question you were asking.
While still in that question 3, there's another one that says, at question 3, what about the 2 at the top? That wasn't cancelled. I think the sum is not correct. Please correct me if I'm wrong.
Which 2? Okay, let's double check. So we had x times x, which was x squared. I had 1x over 3. I had negative 2x over 3. And I had negative 2 over 9. And what I did was I added those two like terms. I have a plus 1, and I've got a minus 2, and that gave me the negative 1 over there, so that should all be fine. The LCD is still 3, and you can't simplify that any further, so that would have to just stay negative 2 over 9. So, no, that sum is fine.
All right.
Okay.
We can continue.
All right. Let's carry on. Okay. Let's do this one before we go for another ad break quickly. One thing that never goes away, grade 10 from primary school all the way through grade 10 and through to matric, is that you always have to remember your order of operations, which means BODMAS. Okay, I'm sure everyone remembers the words. BODMAS says if we deal with brackets, then we look at the concepts of multiplication and division, and lastly, we look at addition and subtraction. Okay, so in this sum over here, I've got a times, but I've also got a minus, okay? Which means that we do need to watch out for your order of operations, which means that I'm going to have to deal with this part of the sum first before we can worry about the minus a half, okay? So let's see. First things first, as we said, there's no cancelling over pluses or minuses, so you have to factorize. And I hope you're looking at that x squared minus 1 and saying it's a difference of 2 squares. So you've got x minus 1, and you've got x plus 1, and it's over 3. Then we've got 1 over x minus 1. And for now, that negative a half is going to stay where it is. So can you see now that now this x minus 1 will cancel with that x minus 1, and that's absolutely fine. So what we're left with now is x plus 1 over 3 minus a half. And the second we add or subtract any fractions, we always look for an LCD, which in this case is going to be 6. All right. So we're going to put everything over 6, which means what I do to the bottom, I have to do to the top. So I'm going to times those by 2 and those by 3. This numerator of x plus 1, that needs to get multiplied. Both terms need to get multiplied by 2 there. So I'm going to have a 2x plus 2, and I'm going to get a minus 3. So simplifying that down, I've got 2x minus 1 over 6. And can I simplify further? No. And you cannot do it. Why? Because you would then be cancelling over a plus or a minus. So please watch out for that. Again, it's one of those silly mistakes that gets very frustrating because you know what to do, but you tend to just watch that you don't make any silly mistakes in your exams. Okay. All right, I think we have time to squeeze in one more example, so I'm going to. And I'm going to have a very quick look at this exponent sum over here. A very common type of question that comes up, and again, I'm sure something that you recognize. So let's have a careful look at this. We have got 2 to the power of x plus 2 multiplied by 5 to the power of x minus 1. And that's all over 10 to the power of x. Okay, and we've got to simplify this, okay? So how are we going to start? The first thing you're going to do is we're going to break all our bases, because now we're dealing with exponents, okay? So the 2, the 5, and the 10 are what we call the base of the exponents. They need to be broken down into their prime factors, okay? So let's look at 2. 2 is already a base, it's already a prime number. So we're going to leave that one alone. So 2 is going to stay 2, and it's x plus 2 as an exponent. 5 as a base is already prime. Okay, so I'm going to leave it alone. That's going to stay 5 to the x minus 1. However, 10 is not prime, all right? And remember, prime, just to refresh your memories, is when a number can only be divided by 1 and itself. Okay, now 10 could be divided by 2 and by 5. So we need to break that up. So 10 is 2 times 5, and that is still to the power of x. Okay, so that's the first thing. We break things down into their prime factors. Now that we've done that, we get rid of the bracket. So I've still got 2 to the x plus 2. I've got 5 to the x minus 1. And down below here we have a 2 to the x and we have a 5 to the x. And what's great about this now is that everything is being multiplied. And everything that's being multiplied makes your life much easier because we're going to do this. I'm going to take my base of 2, which is over here and over here. And when we're dividing bases, remember your laws of exponents, when you're dividing bases, we subtract our exponents. So I've got x plus 2, and I'm dividing 2 to the x, which means I'm going to subtract the exponent. So it's therefore left with just minus x over there. And my base of 5, which is to the x minus 1. And I'm going to subtract the exponent again, which is minus x. So x and x cancels to leave us with just 2 squared. Again, x and x cancels to leave me with 5 to the negative 1. And finally, 2 squared is 4. And 5 to the negative 1, remember the rules of exponents, we bring that down to the bottom to make your exponent positive. Okay. Right, I think it's time for a break. We've been doing lots of work, and go get yourself something to refresh you.
Well, this break, Tamlin, it is not that kind of break whereby they need to go anywhere. You need to be here because you're going to be watching a trailer about the new upcoming movie, which is called After Earth, starring by Will Smith and his son, Jaden Smith. After that movie, I'll be giving you a keyword for today's show. That keyword will be your entry to our competition, whereby you could win a double ticket just for you and your friend to come watch out this movie at any cinema from the 7th of June. So to find out more information, here's the trailer. Welcome back, Mindsetters. I hope you've enjoyed that trailer, and now you are inclined on what the movie is all about, because it is all about the global change and all the atmosphere that is changing. Yes, I just told you that our keyword for today, it is atmosphere. Now, I'll be giving you the winners for last week's show on Thursday. If you entered for the competition on Thursday, you might be the lucky person. I'll be giving you the winners. But if you want to be the winner, and the winners for today's show will be announced tomorrow. If you'd like to be the winner, go to our Facebook page and find out how you can enter for this competition. But simply, it is the entry form is on learnextra.co.za/After Earth. Now, the keyword for this show is atmosphere. Atmosphere. I'll post that keyword also on our Facebook page. The winners for last week's show on Thursday, the first one is Mpumelelo Ngema. Well done to you. You have won yourself 2 tickets to come see After Earth. And another winner that we have after Mpumelelo Ngema is Rofiwa Nemutanzela. Rofiwa Nemutanzela, well done to you. You have won yourself 2 tickets to come watch out this movie with your friend. And the last winner of these tickets is Balani Ngubeko. Well done to you, Ngubeko. Balani Ngubeko, well done to you for winning these wonderful tickets. Come watch this movie with your friend. Maybe take us along. See you there. The movie is coming soon on the 7th of June. Keep it locked in right here on Mindset Learn Extra. Temlen, let's continue.
Thank you. Okay, right. We're going to carry on with not exponents, with equations, because that also forms a really important part of your algebra paper. Okay, so as I mentioned earlier in the show, we learned about linear equations last year, and what we've done this year is we've expanded on it, okay? We keep linear equations there. However, we've also taught you now the concept of a simultaneous equation, where you solve for 2 different variables. And we've also spoken about the concept of a quadratic equation. So we need to now just be able to identify in an exam which one is which. How would I go about solving these equations? So let's have a look and see. If I've got 3 minus 2 to the x, or not 3 minus 2x, which is equal to 6x minus 1. The reason I can identify that this is just a linear equation, grade 10s, is because they're just x's, okay? There are no x squareds anywhere, and they're never going to be any x squareds. It's not like I would be able to multiply and somehow manage to get an x squared. That's it. There's no x squareds happening there, so that means I have got a straightforward linear equation. Straightforward linear equation, I bring all my terms with a variable to the left-hand side, and all my terms with whole numbers to the right-hand side. That's not going to be a minus 3. And we solve it, which I don't think is too difficult at this point. And I divide by 8. Okay. So that leaves us with just x is equal to the negatives cancel, obviously, and we're left with a half. All right. So that's fine, but just wanted to go over it with you guys, because obviously we need to know how to identify a linear equation. Then I've got a simultaneous equation. Now this is important. You will always get one of these in your exams, and they're always worth a fair amount of marks, and it's an important concept, okay? Just to elaborate on this concept for a second. If I had that linear equation over there, and I had this linear equation over here, if I were to plot the graphs of those, if I were to draw the functions of each of those straight line graphs, it would be a picture which is completely, I'm not drawing it accurately, I'm just drawing a rough sketch. It would be two straight line graphs that would intersect each other at a point, okay? And the whole idea with a simultaneous equation is you are then calculating the point at which those two graphs intersect each other, okay? And you're going to land up with an x coordinate and a y coordinate, which represent that point of intersection. So just putting it into a picture as to what we're doing with a simultaneous, that's what we're doing. We're finding that point of intersection, okay? All right, but how do we do it algebraically? Okay, I've got two equations. I've got 3x plus y is equal to 4. And I've got x plus y is equal to 2. Generally, you'll have one equation that's slightly simpler than another, and that's normally the one you want to focus on, which in this case is going to be this equation over here. Okay, now what we are going to do is we are going to, I'm using what we call the substitution method over here. I'll show you elimination in a second. Using the substitution method, I'm going to make, let's say, x. I'm going to get x on its own, all right? And I'm going to do that by moving y over the equal sign. So what I've got is an equation 1, and I've got an equation 2, all right? And what I then do with these equations is I'm actually going to substitute equation 2 into equation 1. All right, and that's what it's going. This is what it's going to look like. I've got 3, but instead of x, I've got 2 minus y plus y is equal to 4. All right, so I hope you can all see what I've done there. I worked out that x was the value of 2 minus y, and then I said, well, if that's an x over there, we've replaced it with 2 minus y. So hence the word substitution method. I'm substituting a value into the equation. And now let's work it out. If I distribute, I'm going to get 6 minus 3y plus y is equal to 4. That's giving me a negative 2y. And if I move my 6 over, I'm going to get a negative 2. So if I divide by negative 2, I'm getting a value for y of 1. Okay, so that's great. We found the one value. Now let's find the other. And the way we typically do that is I substitute the variable that I've just found. So I'm going to substitute y equals 1. And you can sub it back into any equation. It doesn't matter. But I'm going to choose to sub it back into equation 2. And equation 2 was the x equals 2 minus y equation. So sub it back into the x equals 2 minus y equation. So therefore, what do we have? I've got x is equal to 2 minus, and instead of y, we're replacing that with a 1, and we get 1. Okay, so what we've actually worked out here is that if I were to properly plot those two graphs, the two graphs would actually cross each other at the point where x and y are both 1. Okay. Right, guys, that is the substitution method. Just for the benefit of those of you who have done what you call the elimination method, let me quickly show you that just so that nobody is confused. Okay, the elimination method works like this. We've got the two equations. So I've got 3x plus y is equal to 4, and I have got x plus y is equal to 2. All right. So the elimination method, which also is a kind of a giveaway as to what we're trying to do here, is that we want to eliminate one of the variables, okay? Now, the one variable that's kind of easier than the other at this point is the y, because both of the y's are just on their own, okay? However, if I took equation 1 and I simply added equation 2 to it, plus y and plus y are not going to cancel each other out, so that's not going to really work for us. So what would cancel the y's out is if the one y was positive and the other y was negative. Then that would cancel out. So we can do that by multiplying the whole of equation 2 by negative 1. So by doing that, I would get negative x minus y equals negative 2. And if I took equation 1 and now added it to equation 2, I would have 3x minus 1x, which is 2x. I would have plus y minus y, which cancels out. And I would have 4 minus 2, which is 2. And if you have a look, we get exactly the same x value. The x value is still 1. So you can see that it doesn't matter, guys. Again, there's 2 options available in terms of methods. You use the one that you are comfortable with, the one that you've been working in school. Okay. But what are simultaneous equations doing? You are calculating the point where the 2 functions actually crossed each other, your point of intersection. Okay. Right, so those are simultaneous equations. Okay, let's have a look at inequalities. Inequalities are fairly similar to equations. Obviously, you're finding values for x, but the fundamental difference is this. An equation is finding a value or some values for x. Okay? However, your inequality is finding a whole infinite range of possible values for x, which would be kind of represented on a number line, because we're saying the values for x are everything on your number line from a point onwards or downwards on your number line. So that's the difference. How do we treat it? Well, essentially we treat it just like we would an equation. Okay, so if this was just a normal equation, the first thing I would do is I would distribute into my brackets. I would have negative 2x plus 6, which is less than or equal to 5. Okay, so that's fine. And if it was an equation, what would I do? I would move 6 over, so we can still do that. And I've got less than or equal to, that's going to land up being negative 1. Okay, now here's quite an important thing to watch out for. I now need to divide by negative 2 in order to get x on its own. And what you do to the left-hand side, you do to the right-hand side. But with an inequality, grade 10s, remember if you are dividing by a negative, the sign, your less than sign, turns around and it becomes a greater than sign. So you've got to remember that. If you're dividing by a negative, your sign turns direction. Whichever way it was going, it swaps and it goes in the opposite direction. So just watch out for that. Again, small little thing that could cause you to just have a problem. And when we're solving an inequality, we must always represent your answer on a number line. So we're going to have our number line where I've got a half on my number line. X is greater than or equal to. The way we represent equal to on a number line is we color our dot in, and it's greater than, so it means that it's going up the number line with an arrow. So it's everything on your number line greater or equal to a half. Okay. Right, so there we go. So those are inequalities. And let's see if we can quickly get a quadratic equation done. Okay, so we've had a look at linear, and the way we identify linear is that they are just x's. The highest power of x will only ever be x to the 1. Okay, solving a simultaneous equation, you'll be asked to solve for x and for y. Quadratic, linear inequality is your less than or greater than sign. And remember, if you are dividing by a negative, the sign turns around. Okay, so that brings us to quadratic equations. Let's see what I would do over here. Everyone can see I've got 2 brackets, and when I have that, we need to FOIL those out. We need to get rid of those brackets, which means I'm going to have an x squared. Outers and inners, I'm going to have a negative 5 and a negative 7, which is negative 12. And positive 35 equals 3. Okay, so the key thing to look for here now is that you've got a squared. And because it's squared, it's now quadratic, okay? So the steps of quadratic, you gather all the terms to the left-hand side. And your right-hand side has got to be equal to 0. You need to quickly simplify that. So I've got minus 12x plus, that's going to become 32 equals 0, and we factorize it. So I've got my x and my x, I've got my 8 and my 4, both of them are going to have to be negative. And remember, to now what we do is to solve for x, I make x minus 8 equal to 0, which means that my one answer for x is equal to 8, or x minus 4 is equal to 0, which means that x is equal to 4, and that's the other solution. Right, guys, we've covered quite a lot today in terms of simplifying and factorizing and equations, but point is there's lots of revision that you guys need to go and do, and the only way to get it right is practice. So I hope you guys really give it a good shot and practice for these exams.
Thank you very much, Emily.
Thank
And it's always a practice and a practice and a practice.
Always.
That's maths. That's how maths roll.
It is.
But otherwise, thank you very much.
Thank you so much.
And thanks to you, great times, for watching this show. Remember, your keyword for the After Earth competition is atmosphere. We've posted that keyword on our Facebook page. Also, to enter, go to learnextra.co.za/After Earth. It's just so simple, and you could win 2 double tickets, a double ticket for you and your friend to go watch this movie coming on the 7th of June. But to us, thank you very much for tuning in. We'll definitely see you some other time. Keep practicing.